Okay, hello. Today is 9/24. It is an A day, I believe, which means that today, like last time I recorded a video for you guys, is going to be an asynchronous day, meaning we're not going to meet up in our Teams meeting. Instead, I'm going to make a video for you guys going over all the things that we would be learning in class today. First things first. When it came to the homework, I had a lot of people messaging me. I don't understand the second half of these questions that we have on the homework, because in the problem set we only got through half of the questions, so I'm not really sure how to answer the questions that we didn't go over in class. That's completely fine. What I've got up here is I have the grid from the problem set, so I'm not going to be doing the grid that was from the homework. This is the grid from the problem set, and we're going to pick up right where we left off on the problem set, and I'm kind of go over the questions that we weren't able to answer so that you guys can get a better idea of how to answer them. So the first question we left off, we had just finished part E on the problem set, which means that our next part is part F. F is pretty simple, and I don't think anybody would really have problems with this. Part F is saying give the coordinate pair for each of the following points. Up first, it asks us what the coordinate points of K are. So again, when we're finding our coordinate points, before we do anything, we need to go on our X line. Actually, forgot to label. We need to go along our X line to find our coordinate for X before we can go along our Y line to find our Y coordinate. So let's go along on our X line until we get to where K is. K will drop down a line and we'll hit right here. Right there, that's 5 1/3. So the first part of our coordinate pair is going to be 5 1/3. What's the other half of our coordinate pair going to be? Well, let's take our point and let's bring it all the way on over to the other side to our Y, and it's going to hit right here, 2 2/3. So our Y coordinate is going to be 2 2/3 for K. Then it asks us to find I, B, and C. Well, for I, let's go down 3 1/3. And let's go over that hits at 1 2/3. 1 2 3 1 2/3. That's where I is. It asks us to find out where B is. B is all the way over here. Good news about B, we don't need to drag a line down or drag a line across. Since it's on our x-axis, we can just look at our x-axis to find out what the x-coordinate is. Its x-coordinate, 5 2/3. Its y-coordinate, since it's on our x-axis, that means its y-coordinate needs to be 0. Lastly, it asks us for point C. Point C is just as easy, but in the opposite direction. First, we need to find out what our x-coordinate is. Well, if point C is on our y-axis, that means its x-coordinate has to be 0. And finding the y-coordinate is super easy. It's 5 1/3. Again, I didn't think that anybody would really have problems with F. I don't think anybody did, but wanted to go over that because it's still in that list of problems that we could have had problems with. G is basically taking what we already did and saying let's do the exact opposite. So I'm going to erase what we've done so far just for a clean slate. I'm going to erase what we did. The good thing about this being a video is that if you really wanted to see what was on that board, you could have paused it. And now that I'm telling you this, you can rewind it to then and pause it so that you could see what that board looked like. But we're going to move on to what G is asking us to do. It's naming the points that are located at the following coordinates. So this time, instead of us finding the coordinates for a given point, it's going to give us the coordinates and ask us what point is on those coordinates. First coordinates it gives us is 1 2/3 and 2/3. So remember, 1 2/3, our first number, is on our x-axis, so we need to go 1 2/3. Need to draw a line up from here. From the looks of things, there's nothing else that's going to be on this line, so I'm going to stop at M. So it's probably going to be M, but let's just make 100% sure by going to our y-axis and going over from 2/3. That's going to end us up at M. So that first part of G is going to be M. M is located at 1 2/3 and 2/3. The second thing it's asking for is 0 and 2 2/3. Well, if it has an x coordinate of 0, that means it's going to have to be on our y-axis. So, looking at our y-axis, there's two possibilities. It could either be F or it could be C. So, let's look at its y-coordinate. The y-coordinate it gives us is 2 2/3. Well, if I go to 2 2/3, well, that's right there. That's going to be point F. It's not going to be point C, because as we already found out, point C is at a y-coordinate of 5 1/3, not a y-coordinate of 2 2/3. So the second part of G is going to be F on our problem set. Next on G, it's asking us to find out what is at 1 0. Well, seeing as we have a y-coordinate of 0, it has to be something that's on our x-axis. So, once again, there's two choices. It could either be A or it could be B. Well, let's look at our x-coordinate. That'll tell us. Our x-coordinate needs to be 1, so if we go to 1, well, that's A. It can't be B over there. Plus, we already found out what B was in the last question as well. So the answer for the third part of G is going to be point A on our problem set. Remember, this is for a problem set. This isn't for the homework that you had last night. And the last part of G is asking us what point is at the coordinates 2, 5 2/3. Okay? Well, remember, first we have to look at our x-axis. So we go over to 2 on our x-axis, and we start doing a dashed line up from 2 on our x-axis. And we run into point N, and it doesn't seem like there's really anything else on that line other than point N, so it's probably point N. But we just want to make sure. So we're going to go to our y-axis. We're going to go to 5 2/3. So 5 1/3 2/3. And we're going to draw our dashed line from there. And wouldn't you know it, we do come across point N. So point N is going to be the fourth answer for part G. When we get to H, H is where some of us might have started to get confused, because this is something that we hadn't talked too much about. Hopefully, though, we didn't have too much confusion when it came to that. Once again, I'm going to just erase what we've done so far in that last part of the problem, so that I can have a clean, fresh grid. Part H is asking us which point has an equal x and y coordinate. So, it's asking us for x and y coordinates that are the exact same. So, the easiest one that has the exact same is 0, 0. Then we have 1, 1, and 2, 2, and 3, 3, 4, 4, 5, 5, and then it would be every single third in between there as well. So when it's asking us for what has an equal x and a y coordinate, the number needs to be the same. So see here, this point is 1, 1. The x coordinate is 1, the y coordinate is 1. That means that they have an equal x and y coordinate. We could even draw a line that perfectly follows every single x coordinate and y coordinate that are equal. Everything that's along that line I just drew is going to have an equal x coordinate and y coordinate. So let's look along this line that I just drew and let's find out what point's on this line. Oh, there it is. It's right up here. Point L. Well, what coordinates does L have? Let's make sure that I didn't draw this line wrong. We'll do a dashed line down. And, well, it has an x coordinate of 5. If it has a y coordinate of 5, that means that we did draw that line correctly. Let's go over through point D as we go. And look at that. It hits at the y coordinate of 5 as well. So 5 and 5, obviously 5 is the same number as 5. So L, which lands on the coordinates 5, 5, is a point that has an equal x and y coordinate. So the answer for H here on the problem set was point L. Let's once again erase this so that we can have a clean, fresh board, no line shooting through the middle of it for the next part of this review and finishing up that problem set that we had some trouble with the last part of. The next question on this problem set is giving the coordinates for the intersection of the two axes. Well, we have our x-axis, we have our y-axis. Where do these two cross each other? Right here. We already talked about that. We talked about this literally last question with this is the easiest point. It's at 0, 0. The two lines are going to cross there. What's our other name for this? Our other name for that is the origin. The point on this plane that's 0, 0 where they intersect, that's called our origin. So the answer to this one is at 0, 0, and another name for this point on the plane is called the origin. I erased that 0 a little bit, but that's fine. It's now telling us to plot 4 new points. Don't think that this is another thing that we had any real difficulty with, but we'll go over it as well. Plot the following points. First point it's asking us to plot is 4 and 1/3 and 4. So if we're trying to do 4 and 1/3 and 4, remember, before anything we do our x-axis first. So on our x-axis we're going to go over to 4 and 1/3. We're going to go up to 4. I'm going to have these two come together right here. 4 and 1/3 and 4. That's going to be where I'm going to plot point P. That's where point P is. Point Q is asking us to go to 1/3 and 6. So 1/3 and 6 is going to be right up here. That's where we're going to have our point Q. Remember, we do our x-coordinate first. It lists our x-coordinate first, so that 1/3 is on our x-coordinate, and that 6 is on our y-axis. Point R is at 4 and 2/3 and 1. So let's go to 4, 1/3, 2/3, and then let's go to 1, and let's plot our point there. That's where we plot point R. Lastly, it's asking for point S. Point S is at 0 and then 1 and 2/3. Well, that's super easy. Remember, if it has an x-coordinate of 0, that means it needs to be on this y-axis. So now we just go up to 1, 1/3, 2/3, 1 and 2/3, and our plot point right there. That's going to be point S. It's going to be point S. Question K might have caused a little bit of confusion. It is asking us for what is the distance between E and H. Good news about the distance between E and H. E and H are on the same line. E and H are on the same line, so we just need to find out how long this line I just drew is. So remember, each one of these boxes, we've already determined each one of these boxes is 1/3. So let's go 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3, 8/3. So that line has to be 8/3 long. So this line is 8/3, or if you don't want to write 8/3, or it is 2 and 2/3. That is the distance between E and H. It is 2 and 2/3, or it's 8/3. That's the distance between these. Next question is asking for the length of HD. Let's erase this because this is going to get in the way of us between H and D. This is between H and D. Well, once again, whether it's on the x-axis or it's on the y-axis, one of these squares is still 1/3. So let's go and draw this line between H and D, and we'll count 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3. So this one, 7/3, or 2 and 1/3. Question M is asking, would the length of ED be greater or less than the distance of EH plus HD? Well, let's do a little bit of erasing here just so that we can see things better. So we have this distance plus this distance versus that distance. Forms a triangle. Now, E and H, from E to H, and then from H to D, if I were to get a ruler, which I don't have one right now, if I were to get a ruler, I could measure this, and I could add on this bit, and I could physically compare it to that. But what I can do right now is we know this distance right here was 7/3, right? So let's just take EH and add on another 7/3. 1, 2, 3, 4, 5, 6, 7. This right here that I just drew from E all the way to this is our full distance from E to H and then from H to D. Now I'm going to take my hands and I'm going to hold this right here. This right here is the distance from E to D. If I were to cycle this down, which one of these is longer? E to D or E to H plus H to D? I think it's pretty obvious that the length from E to D is going to be less than the length from E to H and then H to D. The quickest way between any 2 points is always going to be a straight line between them. If you have to do bobbing and weaving, then it's going to take you longer to get there. The last part of that is saying Jack was absent when the teacher, aka me, when I explained how to describe the location of a point on a coordinate plane. Explain using point J. We have point J right here. So how are we going to explain how to find the coordinate of point J? Well, think, what's our first step to finding the coordinate pair of J? Well, we need to draw a line down from J to our x-axis so that we can find its x-coordinate. When we draw that line down from J to that x-axis, we find out that the x-coordinate of J is 3 1/3. Now that we've found our x-coordinate, now we need to do the same thing but with the y-axis. We need to draw a line all the way over here to our y-axis, and that lets us know that our y-axis, our y-coordinate that's on our y-axis is going to be 1/3. So with that, we find out that our coordinate pair is 3 1/3, 1/3. Okay? So these were the final couple of questions that we had on the problem set. Hopefully by answering these on the problem set, it helps you guys finish answering those questions that you still had on the homework. Because the questions on the homework are all basically going to be the same things as the questions that we worked on the problem set. It's just that our points are going to be in different places. So you're going to need to do that yourself. You can't just look at what we've done here and get all of the answers for it. Right now, I would suggest that you pause the video and finish that homework, because from now on, the video is going to move on to new content. Specifically, we're going to get into a new module, and we're going to start actually talking about ratios. Ratios is a completely new topic for us. We might know a little bit about ratios, but now we're going to really get into the meat of talking about ratios. Ratios, as you can see by our definition up here, ratios are a way for us to write numbers when we are comparing two different quantities of different measurements. You're probably sitting at your computer right now with a confused look on your face. Mr. Heisey, what are you talking about? What do you mean different quantities of different measurements? That makes no sense. Well, let's look at our example and it might make a little bit more sense. Our example says that for every 5 shirts that Cameron has, he has 1 baseball hat. As you can see, we have different quantities here. I have a 5 and I have a 1. And we have different measurements. On the one hand, over here we're measuring shirts. And over here we're measuring how many baseball hats he has. We have different quantities and we have different measurements. So we have 5 shirts and we have 1 baseball hat. So let's look at this. For every 5 shirts that Cameron has, he has 1 baseball hat. I'm going to set this up in a tape diagram. That might help us look at this a little bit better. We'll write shirts and we'll write hats. So for every 5 shirts that Cameron has, he has 1 hat. For every 5 shirts he has, he's going to have exactly 1 hat. So if we were to look at this maybe in a table can help too. Look at this in 2 different ways. If he has 5 shirts If Cameron only, for some reason, had 5 shirts, has no other shirts, he has exactly 1 hat then, right? Well, Cameron probably doesn't only have 5 shirts. Let's say, what if Cameron has 10 shirts? Well, for every 5 shirts that he has 1 baseball hat, right? So, let's count up to 10. 1, 2, 3, 4, 5. Well, that's 1 baseball hat. 6, 7, 8, 9, 10. Well, that's 2 baseball hats. So if he has 5 shirts, that means he has exactly 2 hats. Well, let's do, what if he has 15 shirts? Well, okay, let's do our counting again. 1, 2, 3, 4, 5. That's 1 hat. 6, 7, 8, 9, 10. That's 2 hats. 11, 12, 13, 14, 15. Well, that's 3 hats. But wait a minute. I'm starting to see a little bit of a pattern here. Let's go, what if he has 20 shirts? Wait a minute. 10 divided by 5 gives me 2. 15 divided by 5 gives me 3. 5 divided by 5, obviously that's going to give me 1. So I'm going to test something. 20 divided by 5, that gives me 4, right? 20 divided by 5 equals 4. I'm going to write 4 here for now. And then we're going to do that hand thing again just to check. 1, 2, 3, 4, 5. Well, that's 1 hat. 6, 7, 8, 9, 10. That's 2 hats. 11, 12, 13, 14, 15. That's 3 hats. 16, 17, 18, 19, 20. That's 4 hats. Huh. So I could skip forward here. Let's say Cameron he's a collector of shirts for some reason. He has a grand total of 55 shirts. He's got a lot of shirts. He has one for every single day for 2 months, nearly, give or take a couple of days. He has a lot of shirts. He barely needs to do laundry. Can I really quickly find out how many hats he has? Well, if it's the same rule as all of this, then we could just divide 55 by 5. 55 divided by 5, he should have 11 hats. This is what ratios are going to help us with. Ratios are going to help us compare 2 different quantities of different measurements. We've been using this ratio to help us find out how many hats he could have if he has a certain number of shirts. But could this help us in the other way as well? Let's see. Let's say I know for a fact, I've counted them. Cameron has exactly 7 hats. Well, if in order to go from his shirts to his hats we divided, maybe to go the opposite way we need to do the opposite of division. Opposite of division, well that's multiplication, right? So let's see if that works for over here. 4 times 5, well that gives us 20, that works. 3 times 5, that gives us 15, that works. 2 times 5, that gives us 10, that works. 1 times 5, that gives us 5, that also works. We can even do this with this one. 11 times 5 gives us 55. So it looks like that's working. What about 7? 7 times 5. Okay, so he must have 35 shirts. So ratios will not only help us go one way, but they can also help us go the other way. If we know how many hats he has, we can find out how many shirts he has. If we know how many shirts he has, we can find out how many hats he has. There's a specific way that we need to write down ratios. Ratios are written out like this. So it's the first number a colon, and then our second number. We read this as 5 to 1. That's a 5 to 1 ratio. Okay? So for every 5 shirts he has 1 baseball hat. It's 5. The baseball hats, the shirts to baseball hats are in a 5 to 1 ratio because it's 5 shirts to every 1 baseball hat. So that's how we write our ratios. We'll do one more page of practice for this. We'll look at this one. This one says, let me get that out of the way. The co-ed soccer team has 4 times as many boys on it as it has girls. So, we say the ratio of the number of boys to the number of girls on the team is 4 to 1. And obviously it says, we read that as 4 to 1. Well, let's make a table just like we did back before then. Okay, let's make a table. We'll put this at boys. We'll put this one as girls. And we're also going to do one more. We're going to have total. We're going to have a total for the total number of kids on this team. Okay? So obviously, the first thing that we can write down is for every 4 boys, there's going to be 1 girl. Every single time you add a girl to the team, there's probably going to be 4 more boys on that team. Because we multiply our number of girls by 4 to get our number of boys. And in grand total, that means we have a total of 5 people on this team. It's a pretty small team, if you ask me. So I'm thinking we probably want a little bit more. Let's add another girl to the mix. If we add another girl to the co-ed team, the co-ed soccer team we already know has 4 times as many boys on it as it has girls. Meaning, we take our number of girls and we multiply that by 4. What's 2 times 4? 8. Yeah, you're right. 4 times 2 gives us 8. So, if we have 2 girls, that means we have 8 boys. And in total, we're going to have 8 plus 2 gives us 10. If we had 3 girls on the team, that would mean that we multiply our 3 by 8, and our 3 by 4, not by 8, and that gives us 12, with a grand total of 15 people on the team. And we can keep going with this table, but this table is going to be exactly like we had it last time. So every single time we go up 1 here, we have to go up another 4 on the other one. So it's not only, if we multiply, we're not just going to be multiplying this by 2 every single time. It's every single time we get 1 more girl, we get 4 more boys. But let's just say they did their counting wrong. They messed up somewhere along the way. The ratio of the number of boys to the number of girls on the team isn't 4 to 1. It's actually 3 to 2. Now this is going to get a little bit trickier because every single ratio we've had so far has been some number to 1. We had 5 shirts to every 1 baseball hat. We had 4 boys to every 1 girl. But this time, it's 3 boys to 2 girls. So that might cause things to be a little strange. We'll go total as well. So let's look at this. We can obviously do our first one right here. For every 2 girls, we have 3 boys, and for every 3 boys, we have 2 girls, and we have a total of 5 people. So now, instead of being able to add 1 girl, every single time we add girls, we have to add 2 girls. So we're going to add another 2 girls And instead of adding another 4, we're going to actually only add 3. So 3 plus 3 gives us 6. We still end up with 10 people on the team. Well, let's add another 2 girls. 1, 2, 2 more girls gives us 6. And add another 3 boys gives us 9. We still end up with 15 people on the team. Now, this one might be a little bit harder for us to see. Because when we look up here, we can see that, oh, well, 4 divided by 1 gives us 4. 8 divided by 2 gives us 4. 12 divided by 3 gives us 4. 1 times 4 gives us 4. 2 times 4 gives us 8. 3 times 4 gives us 12. 4 divided by 4 gives us 1. 8 divided by 4 gives us 2. 12 divided by 4 gives us 3. But this one right here is a mess. What do I have to divide 3 by to get 2? What do I divide 6 by to get 4? What do I divide 9 by to get 6? What do I have to multiply 2 by to get 3? What do I multiply 4 by to get 6? What do I multiply 6 by to get 9? Is there a number that's going to work for this? Well, there's not going to be a whole number. But when we're going from boys to girls, what do I need to do to get from my boys to my girls? There's a number that I can multiply my girls by in order to get boys. 2 times something is gonna give us 3. Well, if I have an unknown here, what I can do is I can just divide 3 by 2 and that'll give me my answer. If I divide everything over here by 2 and I divide everything over here by 2, it'll give me that. So my unknown, I'll put my question mark here. My question mark is going to equal 3 divided by 2, or I could just write that as 3 halves. 2 times 3 halves is going to give us 3, and that makes sense, right? Because this 2 over here and the 2 on the bottom of the 3 halves, those are just going to get rid of each other. So 2 times 3 halves is going to give me 3. Well, let's see if that works for everything else. 4. If I do 4 times 3 halves, is that going to give me 6? Well, 4 times 3 halves is going to give me 12 halves. And 12 halves is actually equal to 6. Oh, well, that looks like it works. Let's see if it works for 9 and 6. 6 times 3 halves. What's that going to give me? Well, 6 times 3 halves gives me 18 halves. And 18 halves is equal to 9. So it looks like that works. Wait a minute. 3 halves, 3 to 2. But why didn't that work over here? This was, we multiply it by 4. But if this is telling us to multiply it by 4, wouldn't we need to multiply it by 4 over 1? Because if over here, we just can change that colon into that dividing line of our fraction. Because 3 colon 2, 3 halves, it's super similar. It's got this colon bar, and that could be the fraction bar. Does it work for here? It does. 4 ones, well, that's just 4 wholes. 4 over 1 is equal to 4. So if we have a number that's not 1 in our ratios, the way to get from one number to the next is going to be by changing that colon that we have between our two numbers into our fraction bar and using that to multiply or to divide. So with ratios are going to help us be able to compare these numbers, and ratios are going to actually show us what we need to do to multiply a number or divide a number in order to find out what the other number is. What I have for us is I have a couple of questions that I'm going to be posting on Schoology that I'm going to have you guys do. You guys are going to do these questions on Schoology, and they're going to be involving ratios. Again, this video is going to be up, so if you have any questions, you can always re-reference this video. It's like, oh, I can't remember what Mr. Heisey said about this. The good news is this video is still up. You can look back at it. If you have any questions that you feel like I didn't really touch on for what you have for your work, then make sure to send me a message so that I know to respond to you. Same as today's lesson, tomorrow's lesson is also going to be asynchronous. It's going to be online. I'm going to post another video on the same exact channel for you guys to watch, for you guys to learn from. And make sure to ask me questions that you guys might have. Okay? I will see you guys soon.